Hello again, YouTube. Lovell Hawes, again, prior enlisted Marine and history buff, just overall, just does a lot of research. And this time, I'm going to be asking why, and this is going to be one that I'm pretty sure that a lot of you are not really familiar with. Why are we not building maglev trains on a large scale? And let me explain what a maglev train is, where most of you think of train that has wheels that are metal wheels that touch on rails and they move along that way. Maglev trains, on the other hand, use electromagnets and magnets to actually make it so that way, well, say this is part of the train and this is the rail. It doesn't ever actually touch, and the magnetism actually moves the train along the tracks. It is a lot smoother, it's capable of going a heck of a lot faster, and at the same time, it can actually be done through an automated system, automated terminal. Now, why do I favor having maglev trains? Well, I don't know if any of you have actually noticed, the interstate's gotten a little crowded out there, and trains are still the most efficient way of moving large amounts of freight in a relatively short period of time. For example, two are every time I see a Norfolk Southern train go through Buena Vista, there's sometimes I'll see two containers stuck on onto that train, and those containers can be later be put on big rigs. Well, every every one of those every one of those cars that has two of those trailers, that's another two big rigs that are not on the interstate. They're on the railroad tracks going to where they need to go instead. So when you see a train that has hundreds of cars that are like that, that's some cases as much as 300 rigs that are on the road at that point because they're being moved by train. Well, that's a lot of stuff. I've been on the inside of a 53-foot trailer, and I mean, it gets really big. In some cases, you wonder if you're ever going to finish when you're unloading or loading one of these things. So, with that being said, the maglev train can move more of them more efficiently, more quickly, with less people involved than, say, a freight train. The typical CSX, Norfolk Southern, Union Pacific freight train. The diesel electrics as we know them today. And they can do it more quickly, with less maintenance on the rails, and overall, they would be able to do it just in a way that it would make sure that it would actually prevent some of the supply chain issues, and it would actually relieve some of the congestion we're seeing on the interstate. Quite recently, there was an accident up in Fairfield where quite a few people actually died because somebody was not moving smartly between the rigs. Instead of using his turn signal and making sure he had clearance, he was just zipping back and forth between the lanes, and he ended up involved in a wreck where I think it took out like 4 rigs. That's a lot of people that got hurt in that. There was a few people that got killed in that, and that doesn't even mention that the rigs that were destroyed, the cars that were destroyed, and the freight that would have been lost in the crash. I mean, that just made a lot of people's days not really, really bad. And it actually prevented other people from making their day better. Just because one guy was not able to play smartly around the big rigs. Well, if the big rigs aren't there, then that dum-dum might not have caused the crash. So, that being said, the maglev trains, because of the way they operate, like I said, they're more smooth. They aren't as maintenance intensive, and you could even have them put on top of pylon systems right over top of the existing rails. So in some cases, they can actually move the freight in the same way that a traditional freight train could. Or they could actually make passenger line move more quickly. After all, there's some people who still use, say, I happen to know there's an Amtrak station in Charlottesville, and I know there's another one in Norfolk. I've actually been toying around with the idea because I haven't been on a train in years. I mean, I think I was 4 or 5 the last time I was on a train, and it was an old steam engine, just because it was, again, history buff. I mean, I really appreciated riding on a steam engine. That was kind of fun. And but I've actually been toying around with the idea of using an Amtrak train to on my next trip to Virginia Beach anyway. Ride down towards Norfolk and hop a rental car just to keep the wear and tear off my vehicles. And honestly, because of the fact that I really don't like the idea of dealing with New York City or Boston, I'd consider riding an Amtrak train up that way in order to actually see some of the things that I, as a history buff, would love to see. Bunker Hill, the old warship Constitution, the aircraft carrier Intrepid, the Statue of Liberty. Yeah, a few things like that. I would love to see those, but I certainly wouldn't want to drive in New York City traffic. I've been in and out of DC. No, thank you. In fact, I've even considered using the Metro Rail to go to DC the next time I go there. Simply stop in Fairfax, hit the Metro from there. Yeah, so passenger train lines could benefit quite a bit from these things as well. And they're less prone to accidents. They're safer. And it just requires use of magnetism and electromagnetism. So the rails themselves don't even need to be magnetized until the train actually gets there, and then it just needs to have the polarity be one way to pull the train forward, and then reverse the polarity to push the train. So even then, the power requirements are not that big. So that leads me back to my original question. Why aren't we building these things? And with having maglev trains, it would actually take care of a lot of our supply chain issue. It would still require places like distribution centers, like the Walmart distribution center in Mount Crawford, the Target distribution center in Stewart's Draft, the new Amazon distribution center that's being built in Fishersville, and the older one, although it is still very new, up in Clearbrook, to still need a lot of people to basically bring in the freight, to process the freight, and then put it onto the trailers. So it still requires a lot of effort on that. There's not much that I can come up with to fix that for the moment. I've seen it. It's a pretty efficient system. And all three of them. Granted, when it comes to what we call conveyable flow freight, basically it's coming into the distribution center with immediately going through the distribution center to go into a truck, because it doesn't have a chance to actually even hit the shelves. It immediately has a place that it has to go. When it comes to conveyable flow, I believe Walmart's system is a little more efficient than Target's. And I haven't seen Amazon's because I was actually one of the guys putting things on the shelves when I worked with the Amazon distribution center. But I have seen the flow system on both Target and Walmart. They did show me those things. And when it comes to that, like I said, Walmart's is a little more efficient. Actually, a lot more efficient. It's like I would have loved to have had a ton of conveyable flow with the way they're doing things. And So they still need a lot of people to handle these items, and I mean it is a very physically intensive task to do these things. And so if you don't mind working a little bit of muscle and don't mind being isolated from people from time or for sometimes hours at a time, then putting in for those distribution centers would probably be a pretty good idea. Because once you get into the ebb and flow of working a lane set when you're actually doing shipping at Walmart, it might be a couple hours before you even see another soul. As many as 3 hours before you even see anybody else or interact with anybody else. It's especially when you're in the trailer, you are generally handling it all on your own. And when it comes to target receiving, there's a similar story there. When you're unloading the trailer, sometimes you're doing it completely by yourself, or often by yourself. So the trailers that you empty, you did that. You unloaded all 53 feet of that trailer, or in the case of Walmart shipping, you loaded pretty much all 53 feet of that trailer. And I mean, the most you might see of Walmart shipping is somebody who is your end runners, and they'll be coming in bringing pallets into your trailer from time to time. But for the most part, all you got time to do is say, "Hi, how you doing today?" and that's it. Everything else that you're doing is completely isolated. And when it came to Amazon, I was inbound stow. I was putting one of the guys on the order picker, putting merchandise on the shelf. And when it came to that particular task, there was often, yeah, like the most I'd actually see of anybody was when I'd empty my cage and have to go back for another one. Or if I happen to have an issue with some of the items on my cage cart. Yeah, it's like at that point I'd have to go by problem solve, and so the most I'd get to see of anybody is when I was going and doing something that involved problem solver or getting another cage, and that's it. Yeah, so if you don't mind the isolation, like me, where I actually had my fill of customer service. I can't wait till I can get back to work so that way I can get back to that isolation because I've had it with customers that can't be pleased. It's not fun anymore. So, but when it comes to the supply chain, I believe maglev trains would do a lot for it. And while we're at it, can we please double the lanes of all of our interstates? Not only would it be better for us to be able to take, say, 600 trucks off the interstate at a time, but it would do us a world of good to have twice as many lanes to deal around with and designate some of them to the tractor trailers. So that way, those rigs can stay out of the way of those little cars, so that way the little cars don't do something that ends up causing a wreck. Because a lot of people can't fathom the difference between their 3,000-pound car and the 40-ton rig. And to put that in perspective, that's 80,000 pounds. Yeah, it's like it would be a lot safer, cause a lot fewer accidents. We'd be able to move the freight more efficiently again. And there'd be a lot fewer people that get hurt. Critically, a lot fewer people that get hurt. Fewer ER visits. Fewer people going to the morgue. So we need to do maglev trains. These are infrastructure items that absolutely must be taken care of. And this is the tip of the iceberg. And I think I might have a whole series of videos that explains what parts of our infrastructure really need attention and how. And it's like doubling the size of the interstate, I think, would be great. But I ideally, I'd prefer to triple the size of it, preferably without using eminent domain. So go with an over-under system, designate the top lanes or bottom lanes, one or the other, for the tractor trailers, and the other lanes for the cars. So in the case of I-81, right around here, it would be 6 lanes total going one direction, one on top of the other. And you can do that without using eminent domain. I hate the idea of using eminent domain, which is part of the reason why I pointed out that the maglev trains can be put over top of the existing rail system and may be able to move the freight just as more efficiently than the traditional rail system that's underneath of it. So, with that being said, I'm going to leave you with this. I'm a huge fan of maglev trains. We're not ready to build something that I'm even more interested in called Hyperloop. And Hyperloop is actually a train that can almost move at the speed of sound. I mean, we're talking about 700 miles an hour here. And I'd love to see where its research and development goes. I don't know what its safety record is at the moment, but I'm curious as to what it can do. Because in theory, you could actually set up a Hyperloop system from New York to San Francisco and actually get there faster going through the Hyperloop than you could in the air, which is kind of wild considering those big passenger jets can move at about 400 plus miles an hour, and the Hyperloop can almost move twice as fast. And it's like they have some really big restrictions up in the air. For example, they can't crack the speed of sound. So they can't reach supersonic speeds, and the planes, I've seen them, they're not built well enough that even if they were built to go supersonic, they couldn't do it. The airlines won't let them, because once you reach transonic speeds, they become really difficult to control. So this is just as much of a drafter thing speaking right here. Being a drafter, I've actually been taught to, having a drafting degree, I've been taught to design quite a bit. I work with engineers on every front. Some of these things are civil engineers, some of these are mechanical engineers, some of these are electrical engineers. I mean, there'd be engineers all over the place working on this. And a lot of the engineers who are listening to me, some of them are going, yeah, this guy's got a pretty good point. And the last one, I know mechanical engineers are going, yes, transonic speeds are really difficult to control planes when they're not built right. So, and that's part of the reason why I'm looking into an engineering perspective. And this goes back to a little something about myself. Time in general is something that fascinates me. Past, present, future. History buff, wondering what it means for today, and engineering solutions for tomorrow. So this is me trying to engineer solutions for tomorrow. I try not to make all my videos just complaining about something. I try to have a better alternative put in place. These are things that I know going forward with our infrastructure would make all of our worlds better. A lot of these are practical solutions that can be implemented relatively quickly and efficiently. So, I hope that this video finds you well. I hope that you share this video with everybody you know. And I hope you continue to have a good day.